Hello, this is Mr. Bradsby. Pleasure to be back with you today. We're going to look at another idea in mathematics, and that's the idea of a variable. A variable. A variable is a common thing. You've been using them, but you may not know the name of variable. So here's some equations. Okay. 6 plus 5 equals blank. Well, in this case, the blank is a variable. It's there waiting for an answer. And all it is kind of like a hole in your paper, and you need to put an answer in it. 6 plus 5 equals square here. The square is the variable. Something needs to go in there. Now, what would go in there? What would we put in the square? 6 plus 5 is, that's right, 11. So that makes it true. That makes it true. 11 makes it true. But what if I took and put, say 15 in the square? 6 plus 5 is 15. No, that's false. That's false. So see, some things you put for a variable could be true, and some things could be false. Typically, we're looking for those that make it true. So here's 6 plus 5 question mark. I think you've probably seen that. And so the question mark is the variable. What would go in there? Well, the question mark would be 11. Now here's one you may not have seen before. 6 plus 5 is equal to n. N is just like a blank or a square or a question mark. N needs an answer. What would n be? That's the question. N equals. If we want it to be true, n would be 11. So n is a variable. You can use letters, you can use squares, you can use blanks, you can use the question mark. They're all variables. The answers will vary. Okay? So they are variables. That is, they'll vary depending on the problem. Okay, so here's another example. So here we have 3 times blank is 12. So rather than the answer being the variable, this is the variable, the blank. Well, let's think about this. 3 times blank is 12. What do I multiply 3 by to get 12? Well, we know 3 times 4 is 12. So the variable here, the answer, blank, is 4. Here 3 times square is 12. Well, what would the square have to equal? Well, 3 times 4 is 12, so the square would have to be 4. See? Okay. 3 times n is 12. What would n be? Well, 3 times 4 is 12. You see, it makes no difference. These are all variables. And the same thing here. I just used the letter A to give it a variety. You could use 3 times B, 3 times X, 3 times whatever. But 3 times A is 12. What would A have to be? It'd have to be 4. Okay, so those are uses of variables. Here's another example. A plus 7 is 15. What would A have to be? Well, to undo this, A plus 7, we have to subtract 7. You can think of it either way. In my addition fact, 7 plus what is 15? Or 15 minus 7 will give me what A would be. But I know that 8 plus 7 is 15, so A would have to be 8. Okay? So there's another variable problem. We could do one more problem. Let's say n minus 14 is 3. Well, what would I subtract 14 from to get 3? Okay, n then would be the number that I could subtract 14 from and get 3. Well, we're subtracting. You know how to undo subtraction? The inverse operation. You add. You add 14 and 3 and you get 17. So is that true? Yeah, 17 minus 14 would give me 3. So there's some examples of using variables and solving problems. Here are some problems with variables in them. I want you to find the number for the variable that makes the sentence true. So I'm going to put some more problems on here, but I want you to do the page where you solve the problems, okay? And then the teachers will answer any questions you have and check these out. Okay, so you could put me on pause. When you finish all of these problems, then go on to the next page and we'll have another little lesson. Okay, so finish these problems and then go on to the next page. Well, thank you for working those problems. Let's go on and talk about the identity property. You have the commutative, you have the associative property, you have the distributive property. Well, this is another property. A property is something that's always true. Never fails, it's always true. So, what is 1 times 6? And of course, we know our multiplication, and 1 is one of the easiest, isn't it? So 1 times 6 is, that's right, 6. 15 times 1, what is that? That's right, 15. Well, here's 1 times 9. What is 1 times 9? 9. What's 1 times 143? 1 times 143 is 143. So that's multiplication by 1. And what we get is the same answer, don't we? Here we had 6. 1 times 6 is 6. 15 times 1, 15, the same as we started. 1 times 9 is 9. 1 times 143 is 143. So we get the same thing when you multiply by 1. And you know that. You know that when you did your multiplication tables, that 1 was one of the easiest to do. Well, if I use a variable like we did on the previous, if we could say 1 times n. What would 1 times n be? Well, remember, n is any number. It could be 5, it could be 15, it could be 22, it could be any number. 1 times any number, 1 times n. What do you think? How could we represent that? Well, you get the same thing, don't you? 1 times n then is n. Yeah, it's the same. It's the same answer. Just like we did on these others, 1 times n will be n. It's the same. So that's what we have here. How would you say that? The identity property is 1 times n is n. Or if we wrote it out in words, what would you say? What would you say? Well, here's what I would say. Okay? 1 times n is n, then the product of 1, the product of any number and 1. Okay? The product of any number and 1 is that number. One times n is n. The product of any number, and that's what n kind of represents, right? It's a variable, any number we want, and 1, the number 1, is that number. So that's the identity product. It's always true. No matter what you multiply by 1, even 1 times 0 is 0. So that's one some people get confused about. But when you multiply by any number, 0, times 1, you get that number 0. Any number times 1 is that number. Well, you're probably wondering, why are we learning about the identity property? Well, here's an example of why it's kind of nice to know about the identity property. Suppose we have 3 times A plus A. Okay? 3 times A plus A. This is like having 3 apples and add another apple. Okay? But with the identity, if we're not sure, we could say 3 times A plus A can also be written, because the identity says they're the same, 1 times A. So 3 times A plus 1 times A. Well, then that should be 3 apples, 1 apple, 4 apples. Not 4, but 4 apples, 4A. 4 times whatever that variable represents. So you see, 3A and A is 3A and 1A, which is 4A. Isn't that simple? And so the identity, though, helps us, because if you ever see a single variable, you can always write it as 1 times that variable, because that's what the identity says. No matter what you multiply times 1, you get that number. So A is the same as 1 times A, just like we said up here. 1 times n is n, or A is 1 times A. Same thing. They're equivalent. They are the same. Another step I could take would be to show you this is true because the distributive principle. 3 times something plus 1 times something, according to the distributive principle, is 3 plus 1 times that A, which is 4A. Okay? But I think that makes common sense, especially if we look at A like an apple. Well, here's another problem I want to look at. It would be, let's say, 4A subtract A. All right? Well, I'll tell you right off the bat, the answer is not 4. Okay? And I could show you that in numbers. Suppose A is 2. So 4 times 2 is 8, minus, if A is 2, we get 6. We don't get 4, we get 6. So you can't take away the A. You've got to leave the A. It's the variable. It stands for something. But anyhow, then, we can write this as 4A subtract, using the identity, 1A. So what do you suppose 4 apples subtract 1 apple, or 4A minus 1A would be 3A. So again, if A was 2, this was 8 minus 2, or 6. 3 times 2 is 6. So they are the same. This is the same. You got that? 4 times 2 minus 2. 4 times 2 is 8, minus 2. 3A, 3 times 2 is 6, and they are the same. 8, 6, 6. So the identity allows us to make it 1A, so we could add, subtract, or multiply. That's the identity property up here, and we use it so we can add and subtract with variables. So we don't know exactly what the number is, but we can work it. Okay? So I'm going to put some problems here. The first one is an example. 3 times n plus n is what? Well, again, we can write it as 3n plus 1 times n, and we'll get 4n. So that's what I want you to do. I want you to work these problems and give us the answer to the problems. The teachers will go over these with you, and you can ask any questions with them. Okay, thank you. I'm going to put some more problems on here. Once you finish these problems, that's the end of our lesson today. It's a pleasure being with you. Enjoy your mathematics.